Hello everyone, so today I'll be looking at the sign test. I've included your specification point, introduction to statistical testing, the sign test. So what I'm going to do is take you through a scenario and show you the steps of how to calculate this. It can come up on your AS paper and A-level paper, so everybody needs to make sure they know this. So I've made up this scenario. So let's say we are interested in how many words someone can say in a 5-minute period after drinking water and after drinking coffee. So we're putting forward a directional hypothesis, so this is one-tailed, and our hypothesis is this. Participants speak significantly more words in the 5 minutes after drinking coffee than in the 5 minutes after drinking water. And in this experiment, we have 16 participants in total, and our data must be nominal, but ours isn't just yet. We will look at our data set and we will then convert it into nominal data. So if we look at our scenario in detail by putting arrows off of what each part is telling us, we can see that our first part is telling us that we are looking for a difference. So we're interested in how many words someone can say in a 5-minute period after drinking water and after drinking coffee. Our hypothesis is a one-tailed, so this is directional. It can be two-tailed for sign test, it's not a requirement, whereas that looking for a difference is a requirement of the sign test. And another requirement is that a repeated measures design must be used. So we have 16 participants in total in our study. They both do the two conditions. So it's not they do one and then someone else does the other. They are both doing the water condition and the coffee condition. Okay, and also the data must be nominal. Now, to conduct a sign test, it has to be nominal as well. That's another requirement. Ours isn't yet. We're going to have a look at this data set and we will convert it. So just to reiterate, you need to be looking for a difference, you need to have a repeated measures design, and the data must be nominal. If you don't have those, you cannot conduct the sign test. Be very clear that those are what you need to conduct the sign test. If the experiment is looking for an association, so a correlation, you cannot be using this test. So this is the data set that I have made up. You could do exactly the same, put random numbers in and see what signs of difference you get, which we're going to look at. So I've randomly put this in because I think the best way to be able to know what you're doing is to make one up yourselves and practice it, because the practicing process will make you more clear with how it is that this works. So if you look, we've got drink coffee. The first participant, 134 words they said after drinking coffee, whereas when they drank water, there was 167 words that they said. So in this instance, participant 1 said more words after drinking water than they did after drinking coffee. Now the sign of difference, what you do to work that out is take the first column, so the drink coffee, you take that away from the drink water. So if you have 134 minus 167, you get a negative symbol. So if you look now, I've put a negative symbol in the sign of difference column for the first participant. Then you do the same for the second participant. So 165 minus 98, you are left with a positive number. You put a positive symbol and you just go down the column like that. Now you can see also that I've highlighted participant 4 and participant 13. Now the reason for this is because they both scored the exact same. They both said 89 words for drink coffee, 89 words for drink water after they drank those. And then 13, that participant both said 135 words after drinking coffee and 135 words after drinking water. Now in the sign test, if you get a participant that scores the same in both of the conditions, you have to ignore them. So this changes our N number, and now our N number is the number of participants that show a difference. So our N number now is 14 because we have to exclude those two participants. So let's have a look at this now. So how many participants do we have that were pluses and how many were minuses and how many scored the same? So in terms of the pluses, we had 12 participants. In terms of the minuses, we had 2. So the pluses, that means that the participants said more words after drinking coffee in the 5 minutes than they did after drinking water. And the minuses, so that's the 2 participants, that means that they said more words after drinking water in 5 minutes than they did after drinking coffee. Now also remember, I've said that there were 2 participants that scored exactly the same, so they are ignored. So our total number of n, now remember n, a capital N, is the number of participants, and that is now 14, not 16 anymore. So what we do is take the less frequent sign. So we had 2 people that were minus and 12 people that were plus. So we take the less frequent sign, that was the minus, and instead we call that S. So our S value is 2. So what we must do is compare our calculated value. So we call the S value is a calculated value. We've had to calculate that, and we compare it to our critical value at the 0.05 level for a one-tailed test. We do this because that is our level of significance, the probability level that we want to test it against to see if there is a significant difference. And the one-tailed test is because we have used a directional hypothesis, a one-tailed hypothesis. And also previous research is sound, so that is why we are using a one-tailed test. We're quite confident we will find a significant difference because it's one-tailed. We've got previous research that sort of heads in all that direction. So now we're going to have a look at the critical values table, and you will always be given one of these in the exam if you have to calculate the sign test. So I've now included your critical values table. This is just the one from your AQA psychology textbook. Now I've put 2 arrows on, and if you look at the top it says level of significance for a one-tailed test. So this is 0.05. That is the one we are interested in. The column doesn't have to say 0.05. 0.05 is the exact same thing as 0.05. Do not get confused and look at the far right column which says 0.005. That is completely different. You want the 0.05 one. And remember n on the left hand side, we want 14, so that's why the arrow is pointing at 14, and you can see there that our critical value is 3. So that's the value we take away from this table. So the critical value for the sign test is 3 when n is 14 at the 0.05 level of significance for a one-tailed test. Now we have a rule with the sign test whereby the calculated value of S must be equal to or less than the critical value at the 0.05 level of significance. So if we have a look at this, we do have a statistically significant result because in our investigation, our calculated value of 2 is less than the critical value of 3. So the rule that we just looked at is met here. Our S value, 2, is less than 3, which is the critical value. So if we have a look now at how you write up the results, it could be a question of write up the results or how is it significant, and you need to mention these particular aspects. So the calculated S value of 2 is less than the critical value of 3 when n equals 14 using a one-tailed test at the 0.05 level. So the results are statistically significant. Therefore, we accept the experimental hypothesis and reject the null hypothesis. Okay, thank you for listening, and I really do just recommend that you draw out one of those tables which I was using for the data set and put your own numbers in, because that gives you a new example to practice with.